So we get to start chapter 6 today. Chapter 6 has to do with some 3D graphing and how those apply to some logarithms. So there's two sections in this chapter. So in the first section, you're going to learn how to graph some points, some equations, and systems of equations in 3 dimensions. So far in math, we've been graphing in how many dimensions? 2, right? Your x and your y are your 2 dimensions. So now we're going to add a 3rd dimension to that. Yeah, so then you can solve 3-dimensional systems of equations. You'll learn how to use systems of 3 equations and 3 variables to solve problems, include finding the equation of a parabola passing through any through points. And then in the second section of this chapter, you're going to learn some important properties of logarithms that will enable you to solve equations. You will then use these skills to solve a murder mystery. The mystery of the cooling corpse. Sounds like fun, absolutely. Math is fun, right? So today we get to start off with 611, creating a 3-dimensional model. So we're going to learn how to actually plot in those 3 dimensions. So we get to create a model. Look at this little guy. We get to create. Woo! And this will help us in making our 3-dimensional little spaces. And then be able to plot some points and have fun with it.
Do you need to cut stuff?
I made one with cutting and I made one with folding. So we'll decide if you can decide if you want to cut or fold.
So it's like arts and crafts day?
A little bit of arts and crafts day. Yep.
Yippee.
Yeah, exactly. So, 611 is how do I plot those points in 3 dimensions? So that's what we're going to talk about. So 6-1, got a little froggy going on, right? So we need to figure out when it's appropriate, or when are we in 1 dimension, 2 dimensions, and or in 3 dimensions. So there's a couple problems for us to talk about so we know our dimensions and go from there. Sound good? All right. So for A, they want us to know how can we represent the solution x equals 5 graphically. So if we think of when x equals 5, and we've been asked to graph these before, what are some ways we can graph x equals 5? Yeah, like 5 on the x-axis. If you think of a number line, right? 0, 1, 2, 3, 4. Oops, 5. I was thinking it was 4, but it's 5, isn't it? Make that a little longer and throw a 5 in there, right? If we filled in, because it can equal 5, that's a representation of x equals 5. Do you think that's in 1 dimension or 2 dimension or 3 dimension? It's in 1 dimension, right? The only dimension we have up there is like that x dimension, right? So that's where x equals 5. So you can do it as a point. There's another way you can actually do it as well. Anybody know? Could you make a line out of x equals 5? Yeah. So if you thought of this as still being that x-axis, you can draw a vertical line, and no matter where you are on that line, x is always going to equal 5, right? But if we think of just that point on that one spot on that x coordinate or on that x-axis, that would be 1 dimension. Yes?
So we're talking about 3-dimensional graphs. What about like 4th-dimensional graphs?
That puts time and motion into the equation.
And how do you do that?
Carefully. I'll show you a little bit. Once we get to where I can show you a 3-dimension, then I'll show you a 4th dimension, yeah. All right. So for B, They want us, how can you represent the solutions to x plus 2y equals 5? So what do we got? X plus 2y equals 5. So how can we show or graph the solutions for that? What are we going to get? A line. Yep, yep. How are we going to find out that line so we can actually graph it?
Set it up in y equals mx plus b.
You want to do that? That's fine. Yep, we can do y equals mx plus b. So how are we going to do y equals, mx plus b? What are we going to do?
Subtract x.
Subtract x. So 2y equals negative x plus 5, just keeping it in the order of the form. And then what are we going to do? Divide by 2. So y equals, I'm going to write it as 1/2 x plus 5 halves. Just to kind of make it a little easier to see where we... Alright. So if we want to graph this little guy, so now we have our x and our y. What do we want to do first? Find the y-intercept. What's our y-intercept going to be? 5 over 2. What's 5 halves? 2.5, 2.5, right? So that'd be like this guy right here, right? Now what are we going to do?
Find the slope.
Find the slope. So what are we going to do for the slope? So from
Go down 1 over 2.
down 1 and over 2? Or down 2 and over 1?
Should be down 1 over 2.
Good job. Yep, down 1 and then over 2, right? So right about there. Yeah. And then what are we going to do?
Do it again.
Well, we can do it again, yep. And then what are we going to do?
Find the x-intercept.
And then what are we going to do? How many points does it take to make a line? 2, right. So then we could draw our line. Right. Just making a rough little sketch of it, right?
2.
Yeah, that's in 2 dimensions, right? We have our x dimension and our y dimension, don't we? All right. So now we have to come up with, I think that was all of our little questions. So now how can we represent this solution x plus 2y plus z equals 5? Anybody got any ideas what that's going to look like? If we now did x plus 2y plus z equals 5. Because what's that z gonna do? Because it's almost like here was our x, right, and this was our x.
There's 3 variables, so you need 3 ways to plot the graph.
Yeah, we need 3 ways. So we need another axis, right? We got the x-axis, we got the y-axis. Where's the z-axis gonna go?
You would probably do it for like height or something.
Yeah. So, it's kind of hard to show on a video, but so your z-axis is actually going to come through the board. It's going to come like towards you and go back of the board. So here's your x-axis, right, vertical or horizontal. Your y-axis is going to be vertical, and your z-axis is going to come towards you and go to the back, which is going to make it 3-dimensional, right? So we have to make a little 3-dimensional model. So there is a link online on the website to where you can print it off. But I got some copies here for you guys. You to make one for you. So I want you guys to be able to get your little model. Just look at x and y and think of x and y like you normally would look at, right? And then think of just the positives. So I want you to set this up in front of you so that your x-axis is like going to the right, your y-axis is coming up, and then like that z-axis is coming towards you,
What? Where is it? Oh, like this.
right?
I take jumps.
Now they're upside down.
Yeah, they kind of are. But then like this, we'll get into it because you can flip this thing all around, right?
Oh, yeah.
So we're just starting off all in the positives, right? My x is to the positive, my y is positive, and my z is positive. So if we really wanted to think about getting into our negatives, we could take this. This is like, think of that first quadrant, right? And if we sat there and if we kind of rotated it around or flipped it, we could get to our other quadrants and all that good stuff. But we're going to sit here in the first one for a minute. All right? Everybody got their set up the right way? All right. So when it comes to doing our points, oops, I didn't even do it up there yet. You know how they have our x and y coordinates? Right? So when it comes to three-dimensional, you have 3 letters. So like if we wanted to find the point 3, 4, 2, this is our x, our y, and our z, right? So start with your x. So what are you going to do? You're going to go over 3, right? So sometimes even like your little pencil tip helps a little bit, right? So I'm over 3, 1, 2, 3, right? And then my y is up 4, so right? So 1, 2, 3, 4. And then what am I going to do?
Go out.
Yeah, you're going to come towards you, right? And you're going to come towards you too. So like that point is actually like in the air,
No, I'm confused.
right?
Wait, can you explain that again?
Yeah. So my x is 3.
Okay, so I go over 3 on
Yep.
that.
Yep, and then I'm going to go
Up 4
up 4.
from where I am on the X. Okay.
Because isn't that the point 3, 4 on like the xy coordinate plane?
Yeah.
Yep. And then now to get to my z, what do I have to do?
Oh.
I have to come
Okay.
up. So right, so you're suspended up here in air.
I get it now.
See it now? How it's coming towards you?
Yeah.
Right? If it was a -2, where would it be?
Going back to the line.
On the other side of the paper. Does that make sense? Right? Alright. So I got one for you guys. So you guys, we're going to build a rectangle. So now I want you guys to, using your model, here we're going to make a rectangular prism. So think of a Kleenex box. So we got to make a Kleenex box. And they gave us 3 of the vertices, or think of those as the corners within our Kleenex box. So they gave us the 3 vertices. So with using your model, we're going to try and figure out, we technically need a total of 5 vertices, right? If we think of that box. Whoops, sorry. And I can never draw these very well, right? So bear with me. Whoops. Yeah, this would be like the back side and the front. So 1, 2, 3, 4, 5, 6, 7, 8. Those are the 8 vertices. They gave us 3, and so we need to spend a little bit of time playing with our model to see if we can find the other 5 vertices. So I'm going to pause, and while you guys work on that, and then I'll be back in a minute. So these are the other 5 vertices that I came up with.